morning all, I am B. Praveena, Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Okay, today our topic Laplace Transform, Definitions and Terminology. Okay, in the previous sessions we discussed Laplace Transform and that related all topics and that related all problems. Now I'll briefly explain what is Laplace Transform and each and every topic, definitions and that terminology. Laplace transform definitions. What is transformation? Transformation is an operation which converts a mathematical expression to a different but equivalent form. Transformation means what? It is one operation which converts mathematical expression in one form to another form. Okay, to a different but the two are an equivalent form only. That's the concept of transformation. Simply, transformation means which converts one expression to another expression. Next, what is Laplace transformation? That is, let a function f of t, one function that is f of t, be a continuous and defined for a positive values of t. Okay, here I am taking one function that is in terms of t. The Laplace transformation of f of t associate a function s, small s, defined by the equation Laplace of f of t is equal to integral 0 to infinite e power minus st into f of t dt. Laplace of f of t is equal to what? Integral 0 to infinite e power minus st to f of t dt. Here the transformation is in between s to t. Here t is always greater than 0. Okay, simply I'll write that as, okay, here f of s is said to be the Laplace transform of f of t and it is written as Laplace of f of t as Laplace of f. Or what is Laplace of f of t here? That is simply I'll write f of s form. Therefore, f of s is equal to Laplace of f of t is equal to integral 0 to infinite e power minus st into f of t dt. Either I'll write this as simply f of s is equal to integral 0 to infinite e power minus st. What is e power? That is the exponential function here. It is multiplied with f of t into dt. Or one more form, that is Laplace of f of t is equal to integral 0 to infinite e power minus st into f of t dt. That's the formula of the Laplace transform. This is the basic definition of the Laplace transformation. If you know this formula, then this through we got basic formulas. Okay, next I'll explain that. First I'll go through the basic definitions. Okay, that is next one, exponential order. What is exponential? A function f of t is said to be of exponential order. Okay, if limit t tends to infinite, if t is reaches to infinite, then the function e power minus st into f of t is reaches to 0. That means here limit t tends to infinite, then the functional value here e power minus st into f of t is equal to 0. For this case, what do you call that? That as exponential order. That's the concept of the exponential order. If you are taking the limit value of the any function, if it is equating with 0, then that is called as the exponential order. And the next one, whatever the next concept, Laplace transform, sufficient conditions for existence. Okay, then the first one, f of t should be continuous or piecewise continuous in the given closed interval a comma b where a greater than 0. Okay, here what is the function? f of t is continuous, or each and every part of this function, that means that is piecewise, is continuous in the closed interval a comma b, where a greater than 0. And the second condition is f of t should be of exponential order. Already I discussed in the previous part what is exponential. Okay, if the two conditions satisfied, the two are the conditions of the first one, f of t should be continuous or piecewise continuous in the given closed interval a comma b, where a greater than 0. And another one is f of t should be of exponential order if the two conditions for the Laplace transform. Okay, next example for that, Laplace of tan t. Okay, this is does not exist since tan t is not piecewise continuous, right? Okay, we are not dividing the tan t as piecewise continuous. That means for that function does not exist. Okay, that is the tan t has infinite number of or number of infinite. That means tan t is not a piecewise continuous. That is one example for the piecewise continuous. Now I'll go through the basic properties of Laplace transform. That is Laplace of 1 is equal to, these are the basic formulas. Laplace of 1 is equal to 1 by s. Here, what is s? Always s is greater than 0. And the another formula, Laplace of t power n is equal to n factorial by s power n minus 1. These are the basic formulas of the Laplace transform. If you know the formulas means easily we can find out the problems. Okay. Then the second formula of Laplace t power n is equal to gamma of n plus 1 by s power n plus 1, where n is not a integer. Here once you observe the second formula and third formula, one formula of the Laplace t power n as n factorial by s power n minus 1, and the another one is gamma of n plus 1 by s power of n plus 1. And the fourth formula here, Laplace of e power at. What is e power at? That is exponential form, and here t coefficient as a. For that case, Laplace formula 1 by s minus a. 1 by s minus a here, where s greater than a or s minus a greater than 0. This is the formula of the fourth one. Next, Laplace of e power minus at. What is the formula of that? Here it is also exponential function. Then the power is here. T coefficient is the negative value. That means minus a. For that case, Laplace formula 1 by s plus a, where s plus a is always greater than 0. And the next formula, Laplace of sine at. Here sine and that coefficient of t as a. For that case, Laplace formula a by s square plus a square. A by s square plus a square, where s greater than 0. And the another one, Laplace of cos at. Then here the cos at formula is s by s square plus a square. Then that condition is here s is greater than 0. And one more, Laplace of sine hat. Laplace of sine hat means this is hyperbolic function. For that case, formula a by s square minus a square. Once you see the difference between Laplace of sine at and hyperbola of sine, that is a by s square plus a square, and sine hat formula as a by s square minus a square. Only the small difference in the denominator, we have to take that negative of this. In that sin at formula in the denominator as positive. Okay, that's the difference between the two. And next, Laplace of cos HAT. What is the formula of Laplace of cos HAT? HAT means that is also hyperbolic form. For that case, formula s by s square plus a square. S by s square plus a square. Once you observe the difference between Laplace of cos HAT and Laplace of cos HAT, then both the cases the formula is same. That is s by s square plus a square. In that case, s square is always greater than of a square. And next, the 10th formula. This is the linear property of the Laplace transform. That is Laplace of a into f of t plus or minus b into g of t. Laplace of a into f of t plus or minus b into g of t. Once you see here, f of t coefficient is what? A. And here g of t coefficient as b. For that case, I'll take a into Laplace of f of t plus or minus coefficient of g of t as b. I'll take outside that b into Laplace of g of t. Simply I'll write that formula of the linear property, that is Laplace of a into f of t plus b into g of t is equal to a into Laplace of f of t plus b into Laplace of g of t. And one more, Laplace of a into f of t minus b into g of t. That is a into Laplace of f of t minus b into Laplace of g of t. These two are the linear properties for the Laplace transform with respect to the plus, and the other one is minus. Okay, next I'll go through the problems and basic concepts of Laplace transform. For the first question, find Laplace transform of t power 5 plus exponential of 3t plus 5 into e power minus 2t. That is simply I'll write that as Laplace of t power 5 plus e power 3t plus 5 into e power minus 2t. Okay, now I'm using the Laplace concept of this question here. I'll take Laplace inside the function, that is Laplace of t power 5 plus Laplace of e power 3t plus Laplace of e power minus 2t into 5. Okay, then already we discussed in the previous slide the basic formulas of the Laplace transform. Now I am using that formulas for the each and every function here. For that, what is the first part of this? That is Laplace of t power 5. Laplace of t power 5. Here, which is in the form of what? Laplace of t power n. T power n. What is the formula of that? N factorial by s power of n plus 1. N factorial means here, what is the power of t here? 5. That is 5 factorial by s power of 5 plus 1. That is the first formula I am using for the first part of the question, that is Laplace of t power 5 and plus Laplace of e power 3t. What is the formula of Laplace of e power 3t? That is e power at formula. That is 1 by s minus a. That is Laplace of e power 3t is equal to 1 by s minus 3. That is 1 by s minus 3. I'm substituting there. And the another part here, Laplace of 5 into e power minus 2t. I'll write that as Laplace of 5 into e power minus 2t. I'll take 5 outside and Laplace of e power minus 2t. And what about the formula of Laplace of e power minus 2t? That is exponential power as negative. For that case, formula 1 by s plus a. But here, what is a t coefficient? The t coefficient is how much here? 2. That means 5 by s plus 2. Therefore, that value of that Laplace of 5 into e power minus 2t as 5 by s plus 2. Okay. Then, therefore, 5 factorial by s power 5 plus 1 is s power 6 plus 1 by s minus 3 plus 5 by s plus 2. Okay. This is the final answer for the first question. This is very simple question, that is Laplace of t power 5 plus e power 3t plus 5 into e power minus 2t. Answer is 5 factorial by s power 6 plus 1 by s minus 3 plus 5 by s plus 2. Next concept of first shifting theorem. What is the statement of the first shifting theorem? Means if Laplace of f of t is equal to f of s, then Laplace of e power at into f of t is equal to what? F of s minus a. If the given function, the f of t is multiplied with one exponential form, okay, by using first shifting theorem, how it will convert? Directly that formula as f of s minus a. F of s minus a. That is the first shifting theorem. And the second case, if Laplace of f of t is equal to f of s, then Laplace of e power minus at into f of t is equal to f of s plus a. Once you observe here, the function f of t is multiplied with exponential with the negative power as minus a into t. For that case, first shifting theorem, okay, property as f of s plus a. Therefore, Laplace of e power at into f of t is equal to f of s minus a, and the another one, Laplace of e power minus at into f of t is equal to f of s plus a. That are the two cases for the first shifting theorem. Next, second shifting theorem. If Laplace of f of t is equal to f of s and g of t is equal to, what is g of t here? Here the function is divided as if t greater than a, for that case function as f of t minus a, and if t less than a, for that case function as 0. Okay, if t greater than a, for that case the function as f of t minus a, and t less than a, for that case the function as 0. Therefore, the second shifting property for that, Laplace of g of t is equal to e power of minus as into f of s. E power minus as into f of s. Okay. Now, I am using the first and second shifting theorem. Okay. Based problems. Okay. First question. Find Laplace of t power n into e power minus at. Once you see directly for the question, the function is multiplied with here exponential. If any function is multiplied with the exponential function, means for that case directly apply first shifting theorem. That's the main hint for applying first shifting theorem. Once you observe here, the function is here t power n is multiplied with the exponential form, that is e power minus at. For that case, by using the first shifting theorem, how it will convert? That as Laplace of t power n, Laplace of t power n, s changes to what? S changes to s plus A. S tends to what? S plus A. Okay. Then Laplace of t power n formula as n factorial by s power n plus 1. N factorial by s power n plus 1, and s will be changes to s plus a. After writing the formula of Laplace t power n, now I'll write in place of s as s plus a, that is n factorial by s plus a whole power n plus 1. Therefore, the first question by using first shifting theorem, then the first question answer, Laplace of t power n into e power minus at is equal to n factorial by s plus a whole power n plus 1. And the next one, transforms of derivatives and integrals of functions. Okay, then that the formulas here, Laplace of f dash of t is equal to s into Laplace of f of t minus f of 0. This is the first formula of that. That is Laplace of f dash of t is equal to s into Laplace of f of t minus f of 0. And the second derivative of the Laplace, that is Laplace of f double dash of t is equal to s square into Laplace of f of t minus s into f of 0 minus f dash of 0. For the first derivative formula, s into Laplace of f of t minus f of 0, and the second derivative formula, s square into Laplace of f of t minus s into f of 0 minus f dash of 0. And another forms of the derivative formulas here, okay, that is if Laplace of f of t is equal to f of s, then Laplace of t into f of t. If the function f of t is multiplied with the t, for that case, directly apply derivative formula. What is the formula of that? Minus d by ds of f of s. That is equal to minus f dash of s. And another one, if Laplace of f of t is equal to f of s, if Laplace of t power n into f of t, there also function is multiplied with t only, that the power is nth term. For that case, how I'll write the formula? That is minus 1 whole power n into f power of n s. Okay, here n is the power of the t. Okay, that is minus 1 power of n f power of n of s. Here n is equal to 1 means, for that case formula, minus 1 whole power 1 into f dash of s. If n is equal to 2, for that case formula, minus 1 whole square into f square of s. That means we have to differentiate the function twice. Okay, that's the concept of the derivative of the transform. But what is the hint for the derivative of the transform means, here the function is always multiplied with t. For that case, directly apply derivative formula. Next, and the next concept is transform of integrals. Okay, here the transform of integral means if Laplace of f of t is equal to f of s, then Laplace of integral 0 to t f of u du is equal to 1 by s into Laplace of f of s. Okay, previously we discussed derivative formula. Now I'll discuss the integral formula. When we are using the integral formula means, if the function is divided by with the t, for that case apply transform integrals. If the function is multiplied with the t, for that case apply Laplace derivative formula. Okay, now I'll go through these two related questions. First one, okay, find Laplace of t into sin at. Once you observe here the two functions, one is sin at and another one is t. But here sin at is multiplied with what? t. Okay, then directly which formula we are applying for that case? Derivative formula, right? That means here if Laplace of f of t is equal to f of s, then Laplace of t into f of t formula is what? That is minus 1. Here t power as 1. I'll write simply here. For the first question, n is equal to 1. Why? Because here t power as 1. Okay, that is n is equal to 1. Therefore, Laplace of t into f of t is equal to what? That is minus 1 whole power 1 into f dash of s. This is the formula. Then simply I'll write that as minus of f dash of s. Then I'm applying that formula for the given question. Therefore, Laplace of t into sine at is equal to minus of f dash of s. F dash of s means what? Simply I'll write d by ds of Laplace of f of t. But what is f of t here? The function is sine at. That's why I'll write simply minus d by ds of Laplace of sine at. Then minus d by ds. And what about the formula of Laplace of sine at? Already we discussed that Laplace of sine at formula as a by s square plus a square. A by s square plus a square. Then, okay, after writing the Laplace formula, then it will convert minus d by ds of a by s square plus a square. Again, which is in the form of d by ds of u by v. Okay, u by v. Then I am applying the derivative formula for this. That is v into u dash, that is minus of s square plus a square, u dash differentiation as 0 minus v into 2s, that is minus a into v dash. That is here what is v dash? S square plus a square differentiation, that as 2. Therefore simply I'll write divided by v square. What is v square here? S square plus a square whole square. Therefore minus of s square plus a square into 0 minus a into 2s by s square plus a square whole square. From that is equal to minus of here s square plus a square into 0 as 0 minus 2 into as by s square plus a square whole square. Here minus into minus plus, that is 2as by s square plus a square whole square. Therefore, the first question, Laplace of t into sine at. Here two formulas are compulsory. One is Laplace of sine at formula and another one is the function is multiplied with t, means for that case use derivative formula. Here Laplace of sine at formula is compulsory and the derivative formula also compulsory. If you know the two formulas, easily we can find out the answer for the first question. Therefore, the Laplace of t into sine at is equal to what? 2as by s square plus a square whole square. Okay. Next, another question. Laplace of sine 3t into cos t by t. Once you observe, in the previous question, the function is multiplied with the t. But here we can observe, here the function is multiplied with the t. Already I gave one hint for that. Two cases. Okay, if the function is multiplied with the t means in that case apply derivative part of the Laplace. And if the function is divided by t means for that case apply integral formula of the Laplace. Okay. Then the second question is here the function is divided by t. Then the procedure for this, then Laplace of, here once you observe, sine 3t into cos t. Here there is no direct formula in the Laplace. First I'll write, okay, that as, I'll convert that as in the trigonometric form. For that I'm multiplying and dividing with the 2. Okay, that is Laplace of 2 into sine 3t cos t by 2 into t. Once you see, after multiplying and dividing with t, this is the form of 2 sine a cos b. 2 sine a cos b. First, I'll write that formula here. That is 2 sin A cos B formula as sin A plus B plus sin A minus B. Okay. First, I'll convert denominator part with respect to the trigonometric formula. That means here 2 sin A cos B as sin A plus B plus sin A minus B. Therefore, sin A plus B means what here? A as 3t and B as t. After adding the two, that as sin 4t plus sin A minus B, that is 3t minus t, that is sin 2t. That is sin 2t by 2t. Now, here I'll take the constant terms outside. Here 1 by 2 I'll take outside, and the remaining Laplace of sin 4t by sin 2t by 2t. For that case, I am using Laplace, then 1 by 2 into Laplace of sin 4t by t plus Laplace of sin 2t by t. Then directly formula of Laplace of sin 4t by 2t. For that case, integral formula of that cot inverse of s by a. Okay, Laplace of sin at by t formula cot inverse of s by a. But here what is a? A is t coefficient. Here how much that has 4. Therefore 1 by 2 into cot inverse of s by 4 plus again for the second part also Laplace of sin 2t by t, that is also in the form of Laplace of sin at by t. For that case formula cot inverse of s by a. But here what is t coefficient 2? Then I am substituting here that as cot inverse of s by 2. Therefore 1 by 2 into cot inverse of s by 4 plus cot inverse of s by 2. Therefore, the final answer for the second question is Laplace of sin 3t into cos t by t is equal to 1 by 2 into cot inverse of s by 4 plus cot inverse of s by 2. Next topic, unit step function and impulse function. The unit step function is also called as Heaviside unit function. Heaviside unit function is defined as u of t minus a is equal to 0. When it is 0, if t less than a, and another one for t greater than a. Okay, then the formula of that u of t minus a is equal to 0 if t less than a, 1 if t greater than a. This is the unit step function at t is equal to a. It can be also denoted by h of t minus a. It can be also defined by h of t minus a. Next, transform of periodic functions. A function f of x is said to be periodic if and only if f of x plus p is equal to f of x is true for some values of p and every value of x. The smallest positive value of p for which this equation is true for every value of x will be called the periodic function. Already we discussed in the previous sessions what is periodic. What is periodic means if you are taking any periodic value of the function f of x plus p, again repeat the same function means if you are taking any value in place of the p, okay, again the function will be repeated means for that case that function is called as what? Periodic. That means the formula as f of x plus p is equal to f of x. But what are the conditions here? P as the smallest positive value of p, okay, and x for every value of x, p as the smallest value. I'll give an example for that. For example, sin x. Sin x, I'll take the period is p is equal to pi. I'm using periodic function formula, that is sin of x plus pi. Sin of x plus pi means what? That is sin x. Next, sin 2 pi. That is sin of x plus 2 pi. That is also sin x. Here what is the period value? That is 2 pi. We have taken any value of that. Again we got the same function, that is sin x. Okay, that is the concept of the periodic. That formula as f of x plus p is equal to f of x. But I'm using that periodic function for the Laplace transformation. Okay, then the Laplace transform of a periodic function f of t with the period p given by 1 by 1 minus e power minus ps integral of 0 to p e power minus st into f of t dt. Okay, Laplace transform for the periodic function, that is 1 by 1 minus e power minus ps integral 0 to p e power minus st into f of t dt. That's the formula of the periodic. Now I'll go through the questions here. Okay, these are the concepts of the Laplace transform. Okay, these are the brief explanation of the Laplace transform for the each and every definition. And next topic in that unit is inverse Laplace transform. What is inverse Laplace transform? This is the converse of the Laplace transform. Okay, then that the concept is here, if Laplace of f of t is equal to f of s, then Laplace inverse of f of s is equal to f of t, where Laplace inverse, L inverse is called the inverse Laplace transform operator, where L inverse is called the inverse Laplace transform operator. This is completely converse of the Laplace transformation. And the second part here, if f1 of s plus f2 of s are the Laplace transforms of f of t and g of t respectively, then Laplace inverse of c1 into f1 of s plus c2 into f2 of s, that is equal to c1 into Laplace inverse of f1 of s plus c2 into Laplace inverse of f2 of s. This is the linear property of the Laplace transform. This is also same as Laplace transform, but here we are using the operator as Laplace inverse. And the next, that related formulas, Laplace inverse of 1 by s is equal to 1, and next Laplace inverse of 1 by s power n is equal to t power n minus 1 by n minus 1 factorial. And the third one, Laplace inverse of 1 by s minus a, that is equal to e power at. And the Laplace inverse of s by s square minus a square, that is equal to cos hat. These are the converse of the Laplace transform. In that Laplace transform, Laplace of 1 is equal to 1 by s, but here Laplace inverse of 1 by s is equal to what? 1. And there Laplace of t power n is equal to s power n by n plus 1. Here Laplace inverse of 1 by s power n is equal to t power n minus 1 by n minus 1 factorial. And the third one, there Laplace of e power at is equal to 1 by s minus a. Here Laplace inverse of 1 by s minus a is equal to e power at. And the fourth one, Laplace inverse of s by s square minus a square is equal to cos hat. Hat means what? This is hyperbolic form. Next, fifth formula, Laplace inverse of 1 by s square minus a square. This is equal to what? 1 by a into sin hat. And the sixth formula here, Laplace inverse of 1 by s square plus a square is equal to what? 1 by a into sin 80. 1 by a into sin 80. And the seventh formula, Laplace inverse of s by s square plus a square is equal to cos at. This is simply converse of the Laplace transform. There, Laplace of cos at is equal to what? S by s square plus a square. Here, Laplace inverse of s by s square plus a square is equal to cos at. And the eighth formula, Laplace inverse of f of s minus a. that is equal to e power at into f of t. Okay, this is first shifting theorem, same as Laplace transform. There I am using Laplace of e power at into f of t is equal to f of s minus a. Here that converse as inverse Laplace, that is Laplace inverse of f of s minus a is equal to e power at into f of t. And the ninth one, Laplace inverse of 1 by s minus a whole square plus b square. That is equal to 1 by b into e power at into sine bt. And the tenth formula, Laplace inverse of s minus a by s minus a whole square plus b square is equal to e power at into cos bt. And the 11th one, Laplace inverse of 1 by s minus a whole square minus b square is equal to 1 by b into e power at sine hbt. And the 12th formula, Laplace inverse of s minus a by s minus a whole square minus b square is equal to e power at into cos hbt. And the 13th one, Laplace inverse of s by s square plus a square whole square is equal to 1 by 2a into t sine at. T into sine at. And the 14th one, Laplace inverse of s square by s square plus a square whole square is equal to 1 by 2a into sine at plus a into t into cos at. And the 15th one, Laplace inverse of 1 by s square plus a square whole square is equal to 1 by 2a cube into sine at minus at into cos at. And next one, Laplace inverse of s square minus a square by s square plus a square whole square is equal to t into cos at. T into cos at. And the next one, Laplace inverse of 1 is equal to what? Delta t. Delta t. These are the formulas. Without knowing the formulas, we can't do these questions on either Laplace transform or inverse Laplace transform. Okay. Now I'll go through the first question on Laplace inverse Laplace transform. Find Laplace inverse of 2s by s square minus 16. Laplace inverse of 2s by s square minus 16, that is, okay, here I'll take in numerator, I'll take 2 outside, after that it will convert 2 into Laplace inverse of s by s square minus 16. I'll write simply that as 2 into Laplace inverse of s by s square minus 4 square. From that, which is in the form of Laplace inverse of s by s square minus a square. That is equal to what? 2 into cos h at. 2 into cos h at. Here what is a? 4. A as 4. Therefore, the answer is for the first question, very simple question, that is Laplace inverse of 2s by s square minus 16 is equal to 2 into cos h 4t. Okay. Next, that is one example for the basic concept of Laplace transform. Next, I'll go through the inverse Laplace transform derivatives. What is the formula of the inverse Laplace transform? That is, if Laplace inverse of f of s is equal to f of t, then Laplace inverse of f dash of s is equal to Laplace inverse of f dash of s is equal to minus t into f of t. Simply I'll write that as minus t into Laplace inverse of f of s. In place of f of t, I am writing Laplace inverse of f of s. That is the derivative of the inverse Laplace transform. Next, inverse Laplace transform of integrals. Integrals, that concept is here. Laplace inverse of integral s to infinite f of s ds is equal to 1 by t into f of t, that is equal to 1 by t into Laplace inverse of f of s. If the function is in integral, for that case, then the function will be divided by with t, or 1 by t into Laplace inverse of f of s. Therefore, Laplace inverse of f of s is equal to t into Laplace inverse of integral s to infinite f of s into ds. Next. Here, second shifting property in the inverse Laplace transform, that is Laplace inverse of e power minus as into f of s is equal to f of t minus a into u of t minus a. F of t minus a into u of t minus a. If the function is multiplied with the exponential function, for that case the formula as f of t minus a into u of t minus a. Next, change of scale property in inverse Laplace transform. That is, if Laplace of f of t is equal to f of s, then Laplace of f of at. Laplace of f of at is equal to what? 1 by a into f of s by a. 1 by a into f of s by a. Here a is the t coefficient. Okay, in that function t coefficient as a, simply I'll write that as 1 by a into f of s by a. And one more, if f of t is equal to Laplace inverse of f of s, then Laplace inverse of f of cs. That means here s coefficient is what? C. For that case formula 1 by c into f of t by c. F of t by c. Change of scale property means what? The function coefficient is multiplied with another coefficient of either a or c or b. For that case, then the direct formula for that either 1 by a into f of s by a or 1 by c into f of t by c. Next, convolution theorem. What is the concept of the convolution theorem here? If f of t and g of t are functions defined for t greater than or equal to 0, okay, then Laplace of f of t star g of t. Here, whatever is the operator of that star. In that case, formula Laplace of f of t star Laplace of g of t. This is the formula of convolution theorem. That is, the function is Laplace of f of t is multiplied with g of t. For that case, formula as Laplace of f of t star Laplace of g of t. I am using the concept in the next question. That is, first question on convolution theorem. Using convolution theorem, find Laplace inverse of 1 by s plus a into s plus b. 1 by s plus a into s plus b. Then, okay, directly in the given question, directly what they are asking, by using convolution theorem only, you have to find out the Laplace inverse of 1 by s plus a into s plus b. If they are not given in the particular form of the question means, for that case, for this question, directly split the question by using partial fractions. After that, apply the general formulas of Laplace inverse. But here, particularly what they are asking, using convolution theorem for the question. That's why I'm using here convolution theorem. That is, we know that Laplace inverse of f of s star g of s is equal to Laplace inverse of f of s star Laplace inverse of g of s. Then, okay, here the question is Laplace inverse of 1 by s plus a into 1 by s plus b. Then, I'm taking Laplace inverse inside the brackets, that is, by using the convolution theorem, that Laplace inverse of 1 by s plus a star Laplace inverse of 1 by s plus b. But from the Laplace transform formulas, Laplace inverse of 1 by s plus a is equal to what? That is e power minus at. Star Laplace inverse of 1 by s plus b is equal to what? E power minus bt. Therefore, that e power minus at star e power minus bt. Here, the concept of that, let us assume that e power minus at as f of t and e power minus bt as g of t. E power minus at as f of t and e power minus bt as g of t. By using convolution theorem here, f of t star g of t is equal to, what is the formula of that? Integral 0 to t f of u g of t minus u du. Okay, integral 0 to t f of u g of t minus u du. Here, what is f of u from the above step? F of t only, f of u. In place of t, I am substituting u. That means e power minus au into e power minus bt. From this formula, which is in the form of g of t minus u, then I am substituting in place of e power minus b into t minus u. In place of t, I am substituting t minus u into du. Then integral 0 to t e power minus au and integral, I'll write this as e power minus bt minus into minus plus, that is e power bu into du. Then here, what is constant term? I'll take e power minus bt as outside and the remaining as integral 0 to t e power of minus a minus b into u du. Once you see here, the integration part is, which is in the form of e power x. What is the formula of e power x? E power x. And whatever the formula of e power integral of e power 2x, that is e power 2x by 2. Same as here, e power minus of a minus b into u is equal to e power minus of a minus b into u by, here the u coefficient as minus a minus b. I am writing it that as in the denominator, that is minus a minus b, and the limit points are 0 to t. Then e power minus bt. Now substitute the limit points of that. What are the limit points? First, upper limit as t and the lower limit as 0. That is e power minus bt into e power of minus of a power minus b. In place of u, I am substituting upper limit of t, that is t by minus of a minus b minus lower limit of u as 0. If you are substituting in place of 0, e power 0 value is equal to how much? 1. That is e power 0 as 1 by, and the denominator as it is, that is minus of a minus b. Now I am taking the, okay, here the denominator has common, that is e power minus bt by a minus b. I'll take outside, and the remaining after the simplification, that as 1 minus e power minus at into e power bt form. From that, now I am taking outside of the e power minus bt as in, I'll take inside the brackets. From that, 1 by a minus b into e power minus bt minus e power minus at into e power bt minus e power minus bt. From that, 1 by a minus b into e power minus bt minus e power minus at. Here, e power bt minus bt as e power 0. That is 1 by a minus b into e power minus bt minus e power minus at and e power 0 value as 1. From that, therefore, 1 by a minus b into e power minus bt minus e power minus at. By using convolution theorem, Laplace inverse of 1 by s plus a into 1 by s plus b is equal to what? 1 by a minus b into e power minus bt minus e power minus at. Okay, these are the topics in Laplace transform and the inverse Laplace transform, the definitions and the related examples. Okay, thank you. Thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.